So we're talking about solving triangles, right? And one of the things I was doing was starting with the right triangle, which was pretty straightforward, I think. Right? And then moving on to triangles that have any angle measurements. In other words, there's no requirement for them to be a right triangle. And we were exploring and having some fun, so to speak. One of the things that I hope you were picking up on is that there's not necessarily a unique way to go about the problem, although there's ways that you should go about the problem. But more importantly is that there are situations where you may not get a solution, and then there are situations where there might be more than one solution. And I think we saw that in an example that I threw up there, that if you did it a different way, you might have gotten a different answer, and so on. So what I want to do is now just take a step back and try to organize the approach for the different types of triangles that you might get. And in its simplest of forms, a triangle that has no solution would be something that looks like that the length of this side here is not long enough to reach that side. In order for this to be a triangle, let's say that was the length of the side. It wasn't long enough to reach this guy down there. So it's obviously not a triangle. So it's possible that you end up in a situation like that. Now, before we start looking at specific cases, there's another problem, and that leads to situations where you might have more than one solution. And that is the following. Excuse me. So, if you recall that there is this trigonometric identity sine of pi minus theta, I believe, is equal to sine of theta. I think that's the identity, but this can be also rewritten as the sine of 180 degrees minus theta is equal to the sine of theta. So what does that mean? That means that if you have a problem in certain triangles, and you have the sine of something, let's call it theta, is equal to some number, 0.72. I'm just making that number up. The way you solve for theta is you take, so theta is equal to the inverse sine of 0.72. And you're going to get an answer. Get, I'm making these numbers up, no idea. So let's say it was 23.4 degrees. Don't take that as the truth. I mean, this is just made up. It's just an example. Because of this property here, there's the complementary angle that would also produce a sine equal to that. So what you would have to do, so let's say this is theta, but then theta 2 would be equal to 180 minus 23.4 degrees to give you whatever that number is. So you're gonna end up with two angles that actually work for the triangle. Hence, there would be more than one solution in that case. And we saw examples of that where we had different answers. Some people were getting one answer and some people were getting another answer. And that's the reason. Question?
Yeah, would theta 2 be equal to the inverse sign of 180 minus?
No, theta 2 is take this number and subtract 230. So we're gonna, question?
Yeah, I'm just like trying to wrap my head around. So when you solve for theta, you got whatever, like 23.4, and that was your theta. But then you also subtracted it from 180. And why is that?
Because of this property here. But fortunately, it doesn't, you don't have to worry about it in all the types of triangles. It rears its head in the side-side angle situation. So that's the most challenging triangle to solve, because that actually has the possibilities where no solution, one solution, and there's two different perhaps ways you can get that one solution. And then there's two solutions. So you gotta have to consider the cases. And that's what we're gonna formalize that discussion right now. So in the past, we were just introducing the general ideas. We now want to go over how to do that. So we're going to consider just a well, let's do it this way. Let's say you got side, side, side. This is not a problem in terms of solving it, because all three sides are given to you. So you know that it's a valid triangle. If somebody gives you a fake triangle, well, then that's on them, right? So these side lengths are real. So this is little a, this is capital A, this is little b, this is capital B, this is little c, and that's capital C. So we're given those three sides. And no angles. So right off the bat, you know that the law of sines doesn't come into play. You must use the law of cosines. So remember, the law of cosines was a squared is equal to b squared plus c squared minus 2bc cosine of little a. So let's just use that one as our, I mean, you could use one of the other two, that's fine. But well, the other two would be b squared is equal to a squared plus c squared minus 2ac cosine of b. And then the third one is c squared is equal to a squared plus b squared minus 2ab cosine of c. Those are the three cosines. So when you got side, 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 take your pick which one you want to do. So the idea then is to just solve for one of the angles. So let's do that. Let's do it generically. So let's just pick this one. Again, it doesn't matter. So we got, let's say we got, well, I don't know, 2BC cosine of A is equal to B squared plus C squared minus A squared. Would everybody agree with that? All I did was bring this term over to this side and brought the A squared over to that side. Does that look right? And then solving for the cosine of A, this is A squared plus B squared C squared divided by 2BC. So then A is equal to the inverse cosine of this, A squared plus B squared plus C squared over 2BC. So that's how you would find A, little a. And did I do something wrong?
Wouldn't it be the opposite of A squared plus B squared plus C squared?
What do you mean, the opposite?
Because you have 2BC cosine of A equals B squared plus C squared
Yeah,
minus
you're right, so this is negative.
Yeah.
Thank you. Yep. I keep asking, is this right? Everybody doesn't. Okay. So all I did there was solve it for the general case. I mean, you would just plug the numbers in. So this would give angle A. That would give angle A. So now we know this angle. Now, in a side, 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 you now have three sides, and you just found one of the angles. You might have decided to find B instead of, and you might have decided to find C. So everybody, you just pick which one you want and solve for it. Now, it is recommended that you, in general, when you're solving triangles, it is recommended that you use the information given to you as often as you possibly can. As often as you possibly can. And one reason for that is because if you did this and, well, now that you have A, you could in fact choose to use the law of sines now to find the other angles. But what I'm saying is that if in fact you made a mistake here for some reason, then your other answers would be wrong. Or you made a mistake here, then that would propagate and you wouldn't get correct answers. Right? But if you stayed with the information that's given, chances are that you're going to be going down a good path. So with respect to a side, side, side triangle, what that means is to continue using the law of cosines. Right? So you would then pick one of the other two equations and solve for another angle. Let's say you went with B, then you would have B is equal to the inverse